Okay, so today we're going to look at the circulation of blood or blood flow throughout the body. So lots going on here. Let's get started. We're going to represent deoxygenated blood in blue and oxygenated blood in red again. This is a circulatory system of a person who's facing out of the page, so they're looking right at you. So left is right, right is left. All right, so I'm going to begin again in the right side of the heart. So notice we have blue for deoxygenated blood returning to the right atrium. And then from the right atrium, it flows into the right ventricle. And then it's going to flow out of the pulmonary. Remember, this is going away from the heart, so pulmonary artery. And then it makes sense that the blood needs to go to the lungs, which are right next door to the heart. So you don't have to travel very far. So the pulmonary artery is going to take deoxygenated blood to the pulmonary capillaries. Okay, so these are a capillary network where the actual exchange of materials takes place. So they're very, very thin walls, and there's lots and lots of capillaries all throughout, so that you can drop off CO2 and pick up oxygen. So as a whole, this circulatory system that's going from the right side of the heart to the lungs and then back to the left side of the heart is referred to as pulmonary circulation. Okay, so blood from the heart to the lungs and then back to the heart. And it returns to the heart via the pulmonary vein. Okay, so pulmonary vein is going toward the heart, but it's oxygen rich. Okay, and it's going to return oxygen rich blood to the left atrium. From the left atrium, blood's going to flow to the left ventricle. The ventricles will contract and blood will flow out of the aorta. It's going to go up to the head here or down to the rest of the body. So the second circulatory system after pulmonary circulation, we call this systemic circulation. This is where oxygen-rich blood goes to all the systems of the body to drop off oxygen and to pick up CO2. Okay, so the aorta is the largest artery, and then it branches off into several smaller arteries. And arteries, remember, always take blood away from the heart. So there's usually oxygen-rich blood inside arteries, with the only exception being the pulmonary artery, remember? So blood is going away from the heart, A for away. And because the arteries are so close to the heart, because the left ventricle is really large, because its job is to push the blood throughout the body, so it's got like a lot of work to do, but the pressure that the arteries feel right after the ventricles contract is pretty great. So in order to withstand that pressure, if you look at the walls of arteries, they have these elastic fibers, and the walls are pretty thick to withstand increased blood pressure. Okay, really important. Veins a little bit different, because when you get to the veins, pressure is not as high because they're farther away from the heart. Smaller arteries are called arterioles. So the larger arteries branch into smaller arterioles, and then the smaller arterioles branch into what we call the capillaries. So all the cells, all the tissues in your body have access to capillaries. So very extensive, and they're quite thin. So you have a one cell layer thick wall on either side, and the diameter is very small, only allows one red blood cell through at a time, and oxygen diffuses out and CO2 is picked up. Okay, and so we go from red to blue. Remember, it's not really blue, it just kind of loses its bright redness once it drops off the oxygen. And then we now go into veins. Veins carry deoxygenated blood toward the heart. Since they're farther away from feeling the pressure of the ventricle, they experience lower blood pressure overall. And they contain these one-way valves that arteries don't have. And if you look inside a vein, the valves kind of look like this. The blood flow is going toward the heart, and then the valves actually close to prevent gravity from pushing the veins back down. So if you're like a really tall person and the blood's returning from your ankles to the heart, it's going to feel the pressure of gravity pretty greatly. And so in order to prevent blood from pooling all the way in your ankles, the valves prevent the backflow of blood. Okay, there are cases where people's valves break down and you get what we call varicose veins. And that's when you can see like these blood vessels kind of expanding, especially in the lower extremities. And so that's just an indication that the valves aren't working as they should. Okay, one way to prevent this from happening is just movement, okay, because you've got lots of skeletal muscle surrounding these veins, and every time the skeletal muscles move, they actually help put pressure against the veins, and that keeps the blood moving forward. So movement's really important. So if you're like a type of person who's very sedentary or just standing in one position all the time without much movement, it's highly recommended that every so often you start moving around just to get the blood flowing, especially in your lower extremities. Okay, so that's all part of systemic circulation because you're dropping off oxygen at all the different systems of the body, and then you're returning deoxygenated blood from both the head through the superior vena cava and the lower extremities, the inferior vena cava, and then you return back to the right atrium. Okay, and I think that's all. Just note that the capillaries are the third type of blood vessel where actual exchange occurs between blood and the tissues. No exchange occurs in the veins or the arteries. They're just highways. And as I mentioned before, the walls of capillaries are very thin for easier transport, and red blood cells pass through single